Part A of the notes for section 3.1. I forgot to videotape this the other day while we were doing the notes, so I'm going to videotape it now. There is a part B, which is the back side of this handout sheet, or this note sheet. So make sure you're watching this one first. This front side talks about functions, so I'll try to go slow so that you can write everything down. But example 1 basically is talking about inputs versus outputs. So you're looking for which coordinates are the x's and which one are the y's. X is the inputs, y is the outputs. So like in part A, the amount of income tax you pay depends upon your income. If I would think about that as like being an equation, what you're going to do first is you're going to put in your income, and then it's going to spit out your income tax. So basically x is going to be the variable that you're going to plug in, which is your income, and your income tax is going to be the y coordinate, or the dependent variable. This is the independent one, this is the dependent one, or the input and the output. B, suppose a rock is dropped straight down from a high place. Physics tells us that the distance traveled by the rock in t seconds is 16 t squared feet. Sometimes you'll have equations like, or sentences like this, and you will have to determine what we're even talking about. So there's two variables that are happening. One of them is distance, and the other one is time in seconds. So you have to figure out which one depends upon which one. Well, the distance that you travel depends upon how long you've been traveling. So this is going to be my x, or my input value, and this one's going to be the y. The last one, part C, refers to the graph over here. So the Weather Bureau records the temperature over a 24-hour period in the form of a graph. The graph shows the temperature that corresponds to each given time. So if we look here, the x-axis is hours, the y-axis is temperature. So that one's pretty easy when they give you a graph to identify. X is the input variable, y is the output variable. But if you think about that in terms of the story problem, you're going to, the temperature depends upon the time of day. So if you were to have this in an equation, you would plug in the hour that it is during the day, and then out it would spit your temperature for that day. So input, output, x and y. And then defining a function, you're going to have a domain for a function, you're going to have a range for a function. Domain is the set of x's, range is the set of y's. And then you'll have a rule by which each input determines one and only one output. Okay, so your rule is like your function. So like y equals mx plus b is a linear function, or y equals x squared is a function. This one right here is a function. This is your rule that you have. Now, it says determines one and only one output. Okay. So this kind of goes back to when we were talking about what is a function and what is a relation. Everything is a relation. Every time you talk about an x and a y paired together, that's a relation, because x and y are related somehow to each other. But only some relations are functions. Okay, in order for it to be a function, the x can't repeat. So when we did this example, we did x and y, and we talked about Super Bowl. So the Super Bowl winner in 2008 was the Eagles, 2007 was the Patriots, 2016 was the Seahawks, and 15 was the Broncos. Okay. Now, in order for this to be a function, basically what has to happen is one of these is paired up to one of these. I can't have this happen, okay, where 2017 has two winners, the Eagles and the Patriots. You can't have two Super Bowl winners in the same year. Now, what I can have happen is if, let's say we had down here was 2014, and that was also the Seahawks. So let's say the Seahawks won in 2016 and in 2014. I can have one team win in 2 different years, but I can't have 2 different teams win in 1 year. In addition to that, all of my X's have to have a value associated with them. There's not one Super Bowl year that you don't have a winner. But over here, there are a lot of teams that we don't have any winners for. So the Steelers, the Colts, the Dolphins, the Ravens, they didn't win in any of these 5 years here. And that's okay. We can have that, but we can't have anything over here that's not matched up over there. So everything is a relation. Only some of them are functions. And we're going to talk about those in equation format here in a second. But I like relating that to the Super Bowl because you can kind of see that a little bit easier, all right? So determine whether a relation is a function. The tables list values, and this one is a no because the 1 is listed twice for the x-coordinate and the 3 is listed twice for the x-coordinate. if you would map this out, and I plot the points 1, 5, 1, 6, 2, 7, 3, 8, 3, 9, I plot them out like this. Basically, I have two dots that are living like right above one another and two dots that are living one on top of the other over here. And the vertical line test, which we've done before, says that if a vertical line goes through a dot or more than one dot at any place, then it's not a function. So it's not a function because the x coordinates occur, and visually you can see that, again, over here is the reason why, because of the vertical line test. So part B, this one is okay. This is yes, a function, because none of my x coordinates occur. If I plot those and do the vertical line test, it is going to pass. All right. In example 3, find the indicated values. The function or the rule that I have is the square root of x squared plus 1. And then they want us to find f of 3. Basically, that means plug 3 in to your equation. Whenever we plug numbers in, you always plug them in inside of parentheses. So it would be 3 squared plus 1 in parentheses is 9 plus 1, or the square root of 10. Now just leave it as the square root of 10. Don't make that a decimal. Negative 5, if we plug negative 5 in, again, inside the square roots, if we take negative 5 and square it, negative 5 times negative 5 is a positive 25. So that will make 26 when you add 1. If you don't plug it in parentheses, negative 5, just like this squared, means you're squaring the 5 and then attaching the negative. So make sure you're plugging it in parentheses or you will get a different answer. And then when you plug in 0, 0 squared plus 1 is the square root of 1, which is 1. Now, when I ask the kids in class whether that should be plus or minus 1, because usually when we take the square root, it's plus and minus 1, they said no, because the square root was already there. And that is true. If the square root's already there, like it is in this scenario, we did not put the square root in, so it's not plus and minus, it's just the positive. Okay? And then the last one, which is kind of ugly, but it should just make sense like the top ones were. They want us to find f of x plus h given this equation right here. Okay? So my equation is x squared minus x plus 2. When we did f of 3, we just plugged 3 in for x. When we're given f of x plus h, you're just taking x plus h and you're plugging it in to the equation for both of those x's. So it will look like this. X plus h squared minus x plus h plus 2. Okay? We went ahead then and we FOILed out x plus h squared, x plus h times x of h, x plus h, and we get this. And when we combine those two middle pieces, we get x squared plus 2xh plus h squared. Okay? Then we've got that minus x, and we distributed through the negative, so minus x minus h, and then plus 2 on the end there. If you need to pause this video if I'm going too fast, go ahead and do that. If you combine the like terms, you'll end up with, oh, there are no like terms to combine. You can't combine anything. So this is what part A is. This is the answer to A. There's nothing you can combine. That is all that you can do. Now, B looks even uglier, but if you just look at B as a step from A, we've taken f of x plus h, and then all we're doing is subtracting an f of x on the end of it. Okay? So we take what we already have here, which I've written out here, and we're subtracting another f of x, which is just your original, x squared minus x plus 2. Okay? And then above here I have written what we get when we distribute the negative through, which is negative x squared plus x minus 2. And then when you combine the like terms, you get 2xh plus h squared minus h. Okay? So use the step before it to get the next step. Now part C has us do one step further. This f of x plus h minus f of x is the same as what we have here. So if we just divide by h, okay, I did it this way. This part 2xh plus h squared minus h just comes straight from the part B. And I pulled an h out because that's what we're wanting to factor out and reduce. So if you pull an h out, you have 2x left over. You have an h here, and you have 1 left here. And then I cancel my h's out, and I get this. Now, you'll see this format right here, f of x plus h minus f of x over h. You'll see that again on your homework assignment because this guy is the definition or the longhand definition of a derivative, which is what we do in calculus. When we do derivatives in calculus, like finding the derivative of this thing, there is a shorter rule to finding that derivative, which takes like 30 seconds to do. Not as long as what this is, but this is like the definition or the longhand version of finding a derivative versus getting straight from here to here by just doing like a 30-second step. So again, that's something that we will talk about when we get to calculus, but for now, this, they just have us compute the longhand way, but you don't necessarily need to know that that's what derivative means, but that's where that formula comes from if you see that being used quite often. Okay, there we go.